In this video, I'm going to go through two real-world applications for graphing a linear inequality. So this scenario reads this way. It says you can spend no more than $120 on school clothes. Now, I personally think that's a lot, but if that's what you have to spend, good for you. It says here it costs $20 for a pair of pants, $15 for a shirt. Write an inequality to represent the different number of pants, X, and shirts, Y, that you can purchase. Think we want to do here standard form of an inequality, and we do want an inequality symbol. So X and Y, standard form of an equation looks like this. AX plus BY equals C, and I need to use an inequality sign for that equal sign. So less than, greater than, less than or equal to, greater than or equal to. So I noticed that I have a coefficient for my X. If X is pants and pants cost $20, it's going to be 20X. And if I'm also going to be buying shirts, and shirts is my Y, and $15 are the cost for one shirt, and I'm comparing that to the amount of money that I have. Now, I don't want to spend more than what I have, so 120 is going to be the max. Now, you can spend equal to all of the money that you have. I probably wouldn't recommend spending all your money, but if you spend less than or equal to $120, then you should be good to go here. That would make most sense, because you can't spend more than you have. Now, what I'm going to do is solve for my X and Y intercepts, because this is standard form. And so this is how you do it. You set your X term equal to the constant term. So if I have 20X equal to 120, and I divide both sides by 20, my X-intercept will hit at 60 on the X-axis. And then likewise, if I set my Y term, the 15Y, equal to the 120, I'll solve for the Y-intercept if I divide both sides by 15. 120 divided by 15, you might want a calculator for that. You're going to get 8. So I notice on my Y-axis, I'm going to put a point at 8. And on my X-axis, actually, I think I made a big boo-boo here. 120 divided by 20 is not 60. Oops. It's 6. So let me just delete that there for you. Actually, I can do one better. I have one of those handy-dandy whiteouts. So let me just fix that completely. My bad. 6. So I'm going to put a point here on my 6. And now what I'm going to do is track what I'm going down. I'm going down 8 over 6 for my line. Down 8 over 6. Or I can get another point if I reduce this, down 4 over 3. So down 4 over 3. Down 4 over 3. That matches. So that just kind of gives me one more point on the line to be really accurate when I draw. And if you're going to spend less than $120, then our shading is going to be underneath of that line, because I want to spend below $120. So anything in this shaded region would be a solution to the system of you buying pants and shirts at the store. So give in this area two possible combinations of clothes. So find a point, pick any point in this shaded region. Doesn't matter if it's on the line, because that's a solid line, or even just a point inside here. I could pick 1, 3, which would mean in terms of X and Y's, you could buy one shirt and 3 pairs of, oh, actually, I got that backwards. My X was my shirts. No, let me read this. $20 for pants. X was pants, and Y was shirts. Let's make sure I fix that. I'm so glad I should have written it down, but you know, we win some, we lose some. Pants. X is equal to number of pants. And Y represents shirts. Okay, so let's fix this. Y was number of pants. And X is number of pants, Y is number of shirts. I think I have gotten that confused on every level of this video. I'm going to continue here. Another point, you know, even if you want to pick a point like 6, 0, you know, that's a point on your line. So that could mean 6 pants and 0 shirts. Maybe you have all the shirts you want. Or, you know, maybe here's another one here. I picked 3, 2. You could buy 3X for pants and 2 shirts. And all of these would be spending $120 or less. All right, let's see if I can do a little better here explaining the next one. But again, it might have helped if I had written down X was pants, Y was shirts. So here's the next page. You are in charge, it says, of buying prizes for a school contest. 1 strand rosette ribbon costs $2, and a 3-strand rosette ribbon costs $3. So you have some, you know, type of ribbon for the prize. Must be, you know, not so cool of a ribbon and then way more cool of a ribbon if you got 2 or 3 strands. You have at most $24 to spend. So what we need to do is pick here. I'm going to actually use this to kind of help me out here. It says 1 strand of ribbon down here, and that's labeled on my x-axis. So again, in standard form, $2 per 1 strand. And then I'm actually going to label here 3-strand ribbon is going to be the Y. Now, how much does that cost? $3 per 3-strand ribbon. And if we want to think about what we're going to spend, I need to put my inequality symbol in here. And can we have $24 to spend? We want to spend less than or equal to that $24. And normally we have it solved for Y, but here standard form is not solved for Y. Let's fix that. We want $24. So spend less than or equal to the amount of money that you have, $24. Okay, again, I'm going to solve for my X and Y intercepts, and we're going to set our X term equal to 24. 2x equals 24. Divide both sides by 2. My x-intercept will be 12. So I'm going to put a point over here at 12. So you could buy all 1-strand rosette ribbons. You'd buy 12 of them and then no of the other kind. None of them, because 12 is 0. Or if you set 3y equal to 24 and divide by 3, you get y equals 8. So I'll point here on 8. So you could buy only 3-strand ribbons. If you only bought 3-strand ribbons, you'd buy 8 of those and none of the other kind. Or if here I'm thinking about my slope, down 8 over 12, or down 4 over 6, or down 2 over 3. I'm trying to think about that fraction reduced. So from 8 to 12, you go down 8 over 12, or down, reduce by 2, down 4 over 6, reduce by 2 again, down 2 over 3. So that's kind of how I was reducing that. Now if I connect those points with my line, if I spend less than or equal to that $24, any point in this shaded region would be a solution to our buying ribbons and the number of ribbons you could purchase for $24. So pick any point you want on that solid line or inside the shaded region. One combination could be, actually maybe I'll pick that point, 6, 4. That could mean you pick 6 1-strand ribbon and 4 3-strand ribbons. Or maybe you want to pick a different point. Maybe a point like, let's say this point in here. So 7, 2. Maybe that means you buy 7 1-strand ribbons and 2 3-strand ribbons. But any point inside here or on the line would be a solution to your inequality.